All right, so welcome to the seventh dev call. So this call will have a different format than the previous one. We'll jump straight into the review of ZRCs. So there won't be any icebreaker or tech updates. So don't hold me to it quite just yet, but I think we'll do a weekly dev call. And what we'll do is every other dev call will be the regular ones. And then the one after that, we'll have a ZRC focus call on reviewing or presenting ZRCs. And the format I'm thinking about initially is to have 20 minutes for the presentation of a ZRC, and then 5 to 10 minutes to actually discuss the standard, the thinking behind the ZRC, and most likely we'll try to have 1 or 2 judges every time we have a dev call on ZRC in that view after the 20 minutes. And so anyone who has a ZRC, as long as they have a draft with a PR submitted to the ZRC repository, will have the opportunity to present their ZRC, and the presentation is open format. They can choose to focus on the actual draft. They can, if they have a reference contract, go on 7th, on the testnet, and walk us through the actual behavior of the ZRC. So yeah, and because those calls will be recorded, we'll be able to continue this conversation in the Discord channel. And so for this one, I'll take a little less time, probably just 10 minutes reviewing the ZRC2, and more time actually just reviewing the process. All of you who are here, actually we have new members, so it'll be worth it to kind of go through those steps again. Probably for the next couple of months we'll do that, just so that everybody's familiar with the actual submission process for ZRC. So as you can see on the screen, we have the contribution guideline. So the steps to contribute to ZRC are very straightforward. We have a ZRC0 that goes more into the philosophy behind ZRC. It's similar to ERC standards, if you're familiar with the Ethereum ecosystem. Then the second step is to fork the repo. The third is to add the actual ZRC to the repository. And then the fourth is to submit a PR. And if you have assets, icons, or media, you can create a folder called assets and put your media there. And then the actual review process is made out of 4 steps. So you have the draft, which is like the initial version of the ZRC. Ideally, the draft would be what you need to have in order to do a presentation to run the call. And then we could go through a conversation informally with the judges on the call and also on the Discord channel. So then you would have maybe like a ready version. And then obviously we would have a panel of judges, which include Amrit, Anton, Hanban, Jacob, and I believe Edison. So, you know, they're part of the core team, but the actual review process will be transparent because the conversation will be made public. So they would approve. And then the final step is when the ZRC has been implemented. Any questions so far about the process? Okay, I will take that as a no for now. So yeah, so without further ado, I'll go into the ZRC2. So the ZRC2 is a standard for fungible tokens. The author section will be updated to reflect that this was a collective group effort. So Vivat, Hanvan, and Amrit, and I think Edison as well were involved in that process. So that will be updated shortly. And the fungible token standard is based on the ERC-777 as opposed to the ERC-20. So if you're familiar with the ERC-20, you've seen an equivalent contract on our 7th ID, which has a similar method that you're familiar with on the ERC-20. as the transfer method, the balance of, the transfer from. So the rationale behind taking the ERC 777 as the inspiration is there are some existing issues that have been identified, and some of those issues that Cameron actually talked about in the Discord channel. One that I go very quickly over is this idea of having to use the approve method and transfer from method. And for someone who has been allowed to move tokens on your behalf using the transfer from method, let's say that person is called Bob, and let's say that Alice has allowed Bob to move 100 tokens on her behalf, but for some reason has decided to change the allowance to only 10 tokens. If Bob is able to see that transaction in the mempool before it's committed, then Bob could send his own transaction and quote unquote kind of front run Alice transaction. And so Bob would take 100 tokens is previously allowed to. And then when Alice transaction has been approved and changed from 100 to 10 tokens, then Bob will be then able to spend the other 10 tokens. So instead of only being able to spend 10 tokens as Alice intended, Bob will be able to spend 110 tokens. So that's one of the issues. I think another issue is that if smart contracts don't have private keys, so if a user by accident send a transaction to a smart contract, if that smart contract doesn't have a method to send it back, then those tokens are stocked there. I'm sure there's a few other issues, and so all the standards have been introduced. We have the ERC.
But could we argue? I mean, is it even debatable to argue whether the attack that you described is really an attack in some sense? Could you argue that it's the property of the contract where if a certain quota is set for a certain user, then he's allowed to do that, and user has to be, the authorizer has to be careful with that. How big is this concern?
That's a great question. I would say, obviously, ERC-20 is very popular, and equivalent standard on different blockchains are very popular as well. So, and that's the good thing about the ERC-77. It doesn't necessarily force you to make a decision because it's backward compatible with the ERC-20. So it actually has the same method, the transfer from and the approve method. It's more of the allow you to if someone is making do you mind muting this if you're not speaking? So to your point, I wouldn't know necessarily how big of a concern it is. It just seems like ERC 777 is more comprehensive. It allows you to move away from that, which you think that's a concern for your implementation. So actually,
I can also answer the question.
Yeah, go ahead.
So the approved transfer from methods were mostly intended to be used for DEXs,
Right.
And for distributed exchanges, and they just haven't really been relied on as much as they were expected, and so they're actually maintained in the ERC 777 mainly for backwards compatibility. You would probably prefer to have an operator relay those tokens than to use the approve and transfer from methods.
Okay.
Okay, that makes sense. So let's deep dive into the ZRC2. So the couple of things that we'll look into, and it's up to anybody who's doing the presentation to focus on the salient points of the ZRC that they're introducing. So assumption here is that most of you are familiar with fungible tokens. And so we'll focus on the new concept that's introduced in ERC 777, which is the concept of operators, right? So there are two types of operators that the ZRC2 is introducing. We'll have the default operators, and I'll put them here. You can see in the immutable variables, when declaring your smart contract, you'll have the default operators, which is a list of addresses. And we'll also have operators. So I think of them as global versus local operators. As you can think of default operators, they're immutable, so they're always going to be there. But the one thing you can do to limit their control, or if you no longer want them to act on your behalf, is we have a mutable field called revoked default operators, right? So it's you can think of it as a check and balances, so that if originally it made sense to have them do operation on your behalf, maybe in the future it doesn't, and so you can revoke their permission. So that's the first type of operators, right? Kind of like the global ones. And if you see, we have a second operators that is through the operators map. So those are more local operators, and we'll see in the contract we have a reference implementation of the ZRC, which is called the ZRC fungible token .zilla. And so we'll look at where they're being those default operators and operators are being used. Right. So we'll look first at okay, as you can see in the contract definition with the default operator. And then we have one transition called reauthorize default operators. So you can imagine, and this is the subsequent transition, if you revoke the rights of default operators, you can also in the future reauthorize them. So it gives you as a token holder control over those operators, right? And so we have a couple of methods or transitions called operator burns and operator mint. And so following the same philosophy as ZRC-2 for those type of operations, you want to have a specific role to allow certain addresses to control the burning and minting. So you can think of specific use cases where institutions want to have some sort of overview over the number of tokens and being able to have certain accesses or special rights. But it also is to the privy of the users to also control how those special operators can move, burn, or mint tokens. The other type of operator, which I call the local operator, we'll see what kind of permissions they have. So we have the mutable field is declared, which is a mapping of addresses. And so in the first transition that we see is the operator send. So the operator send is the alternative to transfer from. Has a similar fields. We have the token owner, we have the to field and the amount. So it's very similar to the transfer from method. So it kind of serve the same purpose. And then you also have the same access control transitions where you can authorize an address to become an operator, and you can also revoke an operator. As you can see, as opposed to the approve method, which we'll see there at toward the bottom, I should look for it. So in the approve transition, you're also passing the amount, right? Which is kind of like the difference in the model between the ERC20 type of transition versus the ERC-77 type of transitions, right? So if you look at the actual ZRC reference, you'll see that we have the list of transitions, and the first transition kind of really focus on the operators, right? The operators related transitions, like I think from 1 to, I think send, 1 to, I want to say, there's a few transitions there, but I think 1 through 12, those are all the transitions that are introducing this new model. And then 13 to the last transition, which is the total supply or the balance of, you have this transition that you've grown accustomed looking at the fungible token contract on Savant. So it's what, it's 9:19. So okay, I think that was good. So 20 minutes.
Yeah.
Does anybody have any questions or?
I have a question. I have a question. This is something I have a partial answer to, but I would like to hear from other people in case they have more clear answers to it.
Yes, for the data.
So if I compare, let's say, default operators with
If someone is talking in the background, can you mute yourself?
We weren't informed that we went over
I
that.
made myself.
And anyways, I mean, might be something to get built.
Can you hear me?
Yeah, I can hear you. I think someone is in your background. Okay, that works. Go for it.
So the question that I have is the difference between default operators and an approved user. So given the fact that ERC-777 is ERC-20 compliant, to my understanding, correct me if I'm wrong, but to my understanding, the difference between, let's say, you allow someone else to transfer a certain number of tokens, and this thing, if you compare this with the default operators, that default operators have the ability to transfer any amount of tokens, any number of tokens that they want to, right? Or is there any other difference?
No, I think it just enforces a certain thinking around how you provide permissions to another address to move tokens on your behalf, right? I think and this is one of the fixes that people have for ERC-20, which is in the case that I mentioned in the beginning where Alice wants to change the allowance amount, the best way to remove that opportunity for front running is to say, instead of changing the permission from 100 to 10, it's to first changing from 100 to 0 and then 0 to 10, right? And so I think that new model enforces this way of thinking. It introduces obviously the operator that's able to move.
How does that solve the problem? How does that solve the problem given the fact that ERC-777 is ERC-20 compliant?
Well, it's compliant for DEXs. That's my understanding, right? So we don't want to necessarily break the way DEXs functioned, but it allows someone who's worried about those issues to provide or to create a smart contract and to use those methods as opposed to the ERC-20 methods, right? So I think it gives people the choice as opposed to it enforces you to do something different.
And for context, I think the operator pattern was added not necessarily to replace the approved transfer from method. I don't think ERC-777 was prompted at all by the attack, which came out after the standard was put forward, but it's actually just convenience and user experience because the operator can kind of do things based off requests, and you don't even necessarily have to have your wallet on you if the operator is receptive to your request to transfer funds. It's definitely a pattern for abuse.
Yeah, this is exactly my concern, and in some way, the use case was actually because we are working with this partner called XFIS, and one of their requirements was that they would like to handle the possibility where, let's say, user for whatever reason has lost his private keys. And if they had done a KYC or mechanism with them, then they would be able to transfer the tokens on their behalf to a new address that they may provide later on. Which certainly, is, as you say, is more like a design pattern and possibility for certain parties, especially the issuers, to help their users in some scenarios. But it doesn't really solve the, as you said, the problem came much later. So it's just an added feature in some sense.
Okay.
Yes. And ZRC3 extends ZRC2 directly for kind of this reason.
Okay.
That's a nice transition, actually. Does anyone has any more suggestions or questions? I'm taking a look right now.
I think it looked pretty good.
Cool.
I like the new style of Scylla development. Last night I was on Savant, the IDE, and I've noticed that it's definitely a lot easier to read now with the comments and the procedure-based format.
Yeah, I think that in the reference contract, the procedures that we added make the transition a lot clearer and easy to read. So, okay.
I think Gareth also pushed a blog post on procedures, as you had asked a few months back, I think, Cameron.
Yeah, I think I've read it.
Yeah, good point. Yeah, I'll share in the ZRC Discord channel as well, so people can read up on the procedures and how they make your transition easy to read and simpler to think about. Cool. So that's a good transition. Cameron, I'll stop sharing my screen, and if you want to share yours, love to hear about the ZRC3.
So the ERC777 or ZRC2 is inspired by the ERC777, and ZRC3 is basically inspired by this EIP 965 with a couple small changes. The goal is it falls under the category of meta transactions, transactions that can be processed off chain by another party before being submitted to the chain. This one in particular, it adds this idea of a check operator instead of a plain operator, and the check operator has to receive a signed check before they can do anything, and they submit that check to the chain by the send by check function. And as you can see, the signer has to sign the token, the ticker, the the amount, the date of the amounts. I mean, the signature is appended to the end. And that makes it so that the operator can't really abuse, or someone functioning as the operator can't really abuse their power to arbitrarily transfer funds. They have to be prompted by the token owner themselves, and on chain that's validated. So the rest of this token, they kind of just discuss a lot of Ethereum specific pains. ZRC3 was actually a little easier to write because of some of the convenience functions of Zilliqa. So let's start at the top. What are meta transactions? I'll just read this off since it's kind of short. Meta transactions are an emerging standard across smart contracts platforms for smoothing the experience of onboarding users. This is done by enabling an off-chain teller node to act as an intermediary, accepting signed checks for token transfers and paying the fee to engage the transfer on the signatory's behalf. And it talks about the relevant contracts. Basically, the first one is primarily to provide a way for token holders to transfer tokens without needing to go and get gas from an exchange. And here's the abstract. This is a great place to start since we've already done the ZRC2 run through. This just details how it's changed. The core changes are, I did this for at least so that it's obvious that you're not in ZRC2 anymore. I changed all instances of the operator to a teller. And the teller is not exactly like the operator, although the pattern is very similar. And the allowance and transfer functions, I didn't actually remove them yet in my reference implementation, but I suggest that they should just be removed since there are no DEXs on Zilliqa that need backwards compatibility with them yet. that might just help us to improve and get out of the gate learning from some of Ethereum's mistakes. Here, let me move this little frame here. And this is the meat of it, is that a contract-wide nonce for every account has been added so that multiple tellers can coordinate and do normal transactions, and you can do normal transactions on the contract without having this front-running issue. Because like and I'll go into detail about the nonce if you want to hear about it. But basically how it works is the bouncer, the teller, will report your latest nonce so that you can sign it. And if you submit a check to the teller, the only really malevolent behavior they can still do is to censor it by holding on to it for too long or just never submitting it. And now with a nonce across the send functions, you can then just go ahead and invalidate that check by sending a regular transaction, which forces the teller to, if they have a check, send it right away and wait for validations for it to be received before they actually notify the end user. So I think this is it kind of helps with that anti-pattern that I think Amrit was hitting on, that the operator can basically do anything. And if they're the default operator, even if they're not malicious, even if they just get compromised or there's a bug, like you're in trouble and you're barely even benefiting from a blockchain at that point if somebody's just kind of moving things around like it's a database. And yeah, so the last thing is the operator send function has been replaced with send check, and I'm just going to scroll down to that. Most of the rest of this hasn't changed. There's a couple new error codes. Send, and well, actually send doesn't require the nonce. I wanted to keep it backwards compatible, but the procedure send does call for a nonce. So yeah, send check. Send check is the new replacement for operator send. And in send check, you can see there's a few new fields. The check hash, which is submitted by the teller, the check signature, which comes from the token owner, a tip if it's relevant, and the nonce, which could be broken out of the check hash. I just put it here to make it obvious. Hold on. Oh yeah, this is a breakdown of the fields. Let's go from the signature to the implementation. The implementation is oh, I have to share my terminal screen. Hold on. Sorry about that. I guess I could just go to GitHub somewhere. Pretty sure I pushed it. ZRC3, there it is. All right. All right, this isn't gonna work. Call it send check, that's what I called it. There we go. So, hold on, sorry, I'm getting so many blinking Zoom channel notifications. All right, there we go. Still happening, but I'm gonna ignore it. Here we go. Here's the major substantial change. We use this is valid check, which is it's up in the functions. Basically, it just takes the check hash. Sorry, the valid check hash takes the public key, the check hash, and the check signature, and runs it through the short signature validation. And excuse me. And if it's false, then it gives you the nonce or the invalid check error code. If it's true, then we just engage the move as before, and the nonce is handled as the nonce that's submitted. The flip side is the behavior that's changed in the procedure for both procedure burn and procedure move have a nonce built in now, where procedure move assumes that the nonce is the current nonce plus one, the one that's submitted. And that's good because the user has to sign their nonce. So they get the nonce from the teller and they can sign that nonce right away. And then if they go and then send a transaction directly, like with ZillPay, then they don't need to know their nonce. They don't have to go through and find like a service that will provide them the nonce for ZillPay. They can just go through the transaction as normal. The goals here were to prevent the front-running attack that Gareth talked about, and also to prevent the abuse of the operator. I think we've achieved those things. Right now, the contract doesn't fully type check, so I can't actually test it just yet. I wanted to get the draft in, but over the next, I'm not exactly sure how long the draft to submission period will take, but over that period, I think we'll see some refinements, and it'll be a very robust contract. There's actually no existing implementation of a complete implementation of 965, which kind of disappointed me. So it'll be a way that Zilliqa has already leapfrogged its Ethereum predecessors. And with that, I'm going to ask for questions.
Well, thank you very much. It's great. It's a great initiative. I have one question though. It's mostly around the nodes. So if I understand correctly, the purpose of nodes, again, excuse my ignorance because I'm not very familiar with the 965 EIP, but I assume that the purpose of nodes is to prevent replay attacks that can happen, right? Or
Yep, that's
okay.
That's the purpose in this context. Yes.
And that does not necessarily have to match the token owner's actual nodes.
No, not this is an account nonce. Like for
Right.
this coin, it doesn't actually match their overall number of submissions to the Zilliqa chain.
Yep. Okay.
I have a question. first of all, very great job for this standard. I've seen, like from 6 months ago when we started talking about meta transactions until now, I see very much progress. So congratulations for this. I just want to ask a question in terms of, it's not a technical term, it's more as a logic term. So if the user doesn't pay for the gas, who's gonna pay for the gas? How the transaction is processed? You said
that's the teller's function. The teller will pay for gas on behalf of the user, and maybe this is the case where kind of the pattern that you employ is up to you. But I could imagine the classic software as a service model where you say, here's our new token, it's used for so and so. Your first 12 transactions will be free, so that you get in the door and you don't think about KYC and getting gas and all that stuff. And then after that, if you really want to, then you can get a serious wallet and really participate.
Yeah, well, this implementation can be very disruptive for payments, where users maybe they want to make payments, but they don't know cryptocurrencies. For example, with our stablecoin, it's much easier to go to a traditional business and tell them you can use our stablecoin than to tell them you need to go to the exchange, buy the token, have a certain amount, push also the fact of choosing the gas limit, which for us is very simple thing. For many users, that could be a barrier of
exactly.
Yeah. So this is a very good implementation, and you made a lot of work since we firstly talked about this like months ago. So
yeah,
very
it's
looking
true.
forward.
It has been refined a lot. And just per your comment, I know it seems like an anti-pattern to pay gas so that users can just submit 1,000 tiny transactions, but it's part of the implementation off-chain for a tip that the relay the teller can actually enforce. So it's actually a great way for you to say, I'm going to sustain the effort to create a stablecoin wallet by saying, here's the flat rate in our stablecoin for a transfer, and if the price for a transfer fluctuates up and down, up and below, then we retain the difference to pay for development. It's something Ethereum, Vitalik has mentioned for Ethereum before.
Yeah, that should be, or you could provide, you could set a gap on the transactions limit. You say this wallet can make 50 free transactions, for example. After 50 transactions, they need to pay for gas. I don't know how this can be work in technical terms, in terms of development and coding, but the major problem could be what you said, that is users could just push free transactions and the teller basically pays until he has balance left. So this is quite a constraint as of now.
Many of the things that you're talking about, Steve, can be pushed. I'm talking about the implementation details, could be pushed on the on the L2 side, where the teller basically puts any rules that he wants.
Exactly.
Yeah.
I had one continuing with Steve's sort of comment. Maybe it's a stupid question, but I'm going to ask this anyway. This works with tokens, but is it possible to extend this to normal native currencies?
You mean to the Zilliqa coin itself?
Yes.
It's been mentioned. I think the Zilliqa coin works a little bit differently than Ethereum does, as far as like Ethereum's not an ERC20 token, so it has to be wrapped. Contracts can send Zilliqa tokens themselves, right?
Yes, they can.
Then I don't see any reason why not. And in this case, then the teller might be a contract, right?
Yeah.
So I would say yes. Preliminarily, yes. I can't promise, but it makes sense to me.
Okay. Good to hear that. I mean, I was kind of sensing that as well, because there's not much of a difference. The only thing that you may, I'm not sure. Would you have to make? Would you have to somehow match the nonce value, the account's nonce value, and this nonce somehow, or not really?
Well, if you were doing it with the Zilliqa main token, then you wouldn't even need a nonce really. Like the nonce is because this is a separate set of coins, a separate total tally than the one. You could just use the mainnet, and then if it's changed since the check you sent, then you know to just invalidate the check on chain. It won't be processed if the nonce that it's showing for that account now is higher than the nonce that check was signed with.
Mm. And does it, if let's say so yes, we are always assuming that this is something that's very specific to Scylla. If right now I'm assuming that this contract assumes that the actual token from address is a user, not a contract. Do we have a mechanism, or at least in the implementation, are you thinking of ways to have some sort of a callback where the contract gets to know that the recipient indeed need to receive the tokens? Is there any callback in some sense to get to notify of the transfer?
To set that the recipient is different from the sender. Is that what you mean? I mean,
no. Let's say the recipient is kind of, in ERC-777 you have this, I think it's called subscription model or something of that sort, where if the recipient doesn't want to receive, then it can reject transactions in some sense. Reject those transactions.
That's possible to add. It's not part of the reference. The meta transactions are actually used for subscription, but in this case, the signed transactions would be, if you subscribe to a magazine, for instance, and you said, I don't want the December issue, and that was possible, you might just cancel the signed transaction that the teller has just been sitting on, waiting for the month to be correct. I also, the first addition to this to make it more interesting and robust would be to replace some of the nonce features with kind of block numbers or something, so that it becomes like a hash lock compatible. You can, say this check is only valid between these blocks. So I know that the teller is going to want to process it right away at the beginning block because he only has a certain window.
Makes sense.
I have a question as well, and also I think the teller model is much more robust than the operator, so it's a great addition. Can you just walk through like a high level, like how you create the check hash? It's like what?
Yeah, actually. So let me stop sharing this. I'm going to share my whole screen because it's not on my browser.
Okay.
Yeah, let's go to this. Okay, good. The README is here. So I actually went through the preview. And can I full screen this easily? No, okay. So basically, oh, it's not here. Hold on. Oh, I'm in the Z badges folder. That's why. That's ZRC4 sneak peek.
You got a future one, okay?
Or potential ZRC4. I don't want to be presumptuous. But Z badges uses this this operator or teller pattern for non-token transfers. I think it'll be interesting. There it is. Let's do this. All right. So here's what I kind of worked out as the. It can just be a JSON blob which you hash with HMAC and then append each part to concatenate each part, and that should make it so that Scylla should be able to verify it on chain. Right now I'm in between testing it on Savant and testing it on the testnet, and you can't actually send things to Savant as far as I know. It's from off chain, so I haven't been able to test this, but in theory, you make the rest of this. You get the account nonce from your teller. Your teller should be, that's part of why the WebSockets, or at least substate based method calls are so important, because the teller has to have an up-to-date understanding of the nonces, or else people are going to be sending it checks that it can't even cache. So it gets the nonce from the teller. It fills out this whole JSON blob. The client hashes it, signs it, and then I don't actually have an example of the teller's transaction, but this all is sent as one of the transition call parameters. And the contract I showed you doesn't have the full hash and signature verification validation code implemented yet, but it should be, once it's done, very flexible so that you can add, my teller doesn't have a fee, or my teller has this thing, and it can still validate that piece of the data has been sent from the user and not set by the teller.
Okay, that makes sense. And probably another new question, but the signature that you send with, is that different for every single transaction, or is it the same?
No, it has to be different. It's a signature of the rest of this block.
Okay.
That's part of the value of the nonce, is it guarantees that each transaction hash is going to be unique.
Okay, makes sense. Cool.